I told you we'd be back pretty soon to talk about the pH of bases, and I meant it. Okay, pH of bases. Think about what we know about the pH scale and what we know about pH. pH scale, 0 to 7 is, or below 7, I guess, is acidic, 7 is neutral, above 7 is basic. And we know that an acid is all about the hydronium ion concentration, even though if I have a basic pH, I can calculate a hydronium ion concentration. I know that bases generally aren't hydronium, okay? But I know where the hydronium comes from with acids, and I know how to calculate the pH of an acid. And if I had the pH, I know how to figure out concentration. I want to be able to do all of those things with a base. So what about bases? Well, first of all, bases increase the concentration of hydroxide. So even though I can get a number for pH of a base, and I can use that to calculate hydronium ion concentration, I'm never actually working with hydronium, I'm working with hydroxide. And I get the hydroxide for strong bases anyhow by direct dissociation. And then this is the question that we're answering today. And actually that's the other question that we're answering today. Same two questions that we had from before, it's just now with bases. Okay, now I've called it the eccentric cousin. It's probably a little unfair from me, but there's another scale that you've probably not heard of. So you are now one of the select few that know about the POH scale. And the POH scale runs from 14 to 0, actually a little bit above 14, a little bit below 0, and 7 is neutral. And anything from above 7 is now acidic, and everything below 7 is basic. So it's the same scale, except now tuned into bases. And where bases get more basic, the numbers get smaller, just like where pH, as acids get more acidic, the numbers get smaller. So all those same rules apply. Well, how come you've never heard of the POH scale? The reason is really simple, is because I can get pH numbers for bases using this relationship on the bottom. That if you look at how the scale lines up, it's always pH plus POH add up to 14. We're not going to talk about why that is, at least not in this course. Okay, well, how does that work? Well, the easiest way to think of it is to think of P as not really meaning something other than a mathematical operation, where it means the negative log of something. Okay, and if we do that, and if we kind of remember that, it'll help us later on too. Not this course, later on even. So pH is the negative log of the hydronium ion concentration, and acids are about hydronium. So if I want to talk about an acid, I want to find the concentration of hydronium, and that's really the hydrogen, remember? So that's going to give me the negative log of hydrogen. So if I want to talk about a base where I know hydroxide, then I want the negative log of hydroxide. I want to talk about the POH. But nobody knows what POH is, so I have to convert that back to pH so that everybody knows what I'm talking about. It's really not that much more complicated. So, how do you calculate the POH? Same way. If I give you numbers like I gave you for acids and ask you to calculate the POHs and ask you to pause the video now and do that, you can do that. You can do that. Hopefully you did that. But these are the numbers. And you'll notice that the numbers look kind of familiar in the sense of whatever numbers I would have gotten if this was a pH, I'd get kind of similar numbers for POH. Mathematically, they're identical. So now it becomes your job to know whether we're talking about an acid or a base. Is the number you just calculated pH or POH? Okay, if I know the POH, but I want to know the pH, I just do 14, subtract that number. And again, you can pause the video and you can do 14, subtract that number. You could probably do a couple of these in your head. You could probably do them all in your head. And then you get the pH numbers, and you'll notice that our pH numbers now are basic. So, no surprise. Okay, what if I want to start with a base? Easy. I'm going to find the POH of that base. I guess first I have to find the concentration, but if it's a strong base, that's easy. Find the concentration, find the POH rather, and then do 14, subtract the POH, and I get the pH. Okay, so the question will look something like that. So you can do that, find step 1, do step 2, Bob's your uncle, life is good. Okay, what if I know the pOH? Same kind of thing as before, is I'm going to do 10 to the exponent negative P, well in this case, OH. So that was how I found the concentration for an acid. Okay, remember that? Looks familiar? If I'm going to do the same thing for a base, then it's going to be 10 to the exponent negative pOH, which I probably should have written down, but I didn't. So there you go. Concentration of hydroxide is 10 to the exponent negative pOH. Same as the acids. Okay, so if you know a basic pH, so you got a pH of 11 or 12 or something like that, you calculate the pOH, you calculate the concentration of hydroxide. Pretty much the same thing except for that top line where we have to then turn it into the base term of it. Okay, so there's a question. Okay, so write that down perhaps. At least follow along, but you really should be pushing the buttons on the calculator. So first find the pOH, because a pH of 11.6 doesn't help me find the concentration of the base. I need to know the pOH. In this case it's 2.4. So then 10 to the exponent negative 2.4 is 0.004. Don't forget the moles per liter units. Okay, I'm going to leave you with some reasons. Now, understand that there's a couple of different ways we can get that concentration, right? So we don't have to be given the concentration, we might have to calculate the concentration. But once we know the concentration, it's this all over again. Okay, and then for you to calculate the concentration of hydroxide. Too easy. Okay, this might be a helpful, I don't know what you want to call it, thing. Because if I start in one of the corners, like I'm starting with hydroxide and I want to find the pH, then hydroxide, follow the arrow, which is pOH is negative log, follow the arrow to get to pH. If I'm going from pH to concentration of hydroxide, I'm going back. Pretty easy, pretty simple, pretty straightforward, but you can't cut corners, and that's what's really important. Okay, that's about all there is for me today. We'll talk to you in class.